Okay, so can you see my board okay?
Yes.
Okay, excellent. All right, here we go. So if I draw a little something like this, you go ahead and name this molecule for me. Okay, if say that, what is that?
I did is carbon.
Huh? Carbon, and I'll draw it like that as well. See, oh, excuse me. Yeah, let's go with CH4. Sorry. So a carbon bonded to 4 hydrogens.
Uh-huh.
Okay.
Okay. Mm-hmm.
Okay. So that would be methane, right? We have one carbon and 4 single bonds. So that's methane.
Okay.
All right. And C2H6. So we have meth, eth, prop, and bute. That's 1, 2, 3, 4 carbons. We draw that. One carbon, 2 carbons with, and I won't put all the hydrogens on, those are just single bonds to other hydrogens. That's ethane. Okay.
Okay. Uh-huh.
All right. And then how about this? And if we have 3 carbons bonded to hydrogens, remember what that one is?
No.
Okay. So meth, eth, prop. So that's propane.
Propane. Okay.
Yep, exactly. And we'll do one more. So I have 4 carbons bonded, all single bond to hydrogens. Not enough hydrogens.
That one is propane or something.
It is butane, exactly right. 4 carbons bonded to 10 hydrogens. So that is fully saturated with hydrogen bonds. Okay, and you go butane, pentane for 5 carbons, hexane for 6 carbon, heptane for 7, on and on and on. Okay,
Mm-hmm. Mm-hmm.
great. So let's go. So that's all single bonds. So if we have something, that would be, so So let's check. Both those carbons have their 4 bonds. We have 1, 2, 3, 4 bonds. And to this carbon here, 1, 2, 3, 4. So it's got all of its covalent bonds, right? 2 carbons, right? Oop. And then above, remember, 2 carbons was a butane. But in this case, 2 carbons, since we have a double bond between carbons, we have a, excuse me, not but, that's 4. F. Before we had ethane, but since we have these 2 carbons, we have ethene.
Okay.
So now we did the alkanes, now we're into the alkenes. Naming convention say the same with F. And up above, it was ethane. Now we have ethene.
So I have a very good question. So the A changes to B because the double bond, right?
That is right,
Okay.
right there.
Let me just write it down.
Hmm.
Okay. Okay.
Okay, so now we have 3 carbons and a double bond. Okay, so methyl, ethyl, propyl. So we know we have prop.
Yeah, because it's 3 carbons.
It is 3 carbons exactly, and we have a double bond, and we know that is propane. propene. Okay, as opposed to the propane when it was all single bonds.
Okay. Sorry, I'm taking notes.
Oh, yeah, absolutely. This is very important that you understand the naming convention because, like, as you're probably noticing, if you don't even know kind of what the professor is talking about, it makes it really hard to follow along.
Oh, yeah. Yeah, okay.
Okay. Okay, so let's do one more of the alkenes, right, with E. Let's move it up to 1, 2, 3, 4. Now, see, it's going to matter where I put that double bond now, right? We're going to have to specify where it's at. It didn't matter before because I could move this double bond over here. Doesn't really change it. You see, you can flip it either way. It's the exact same thing. However, now that I have 4 carbons, it's going to matter greatly. I can put it here, which is going to be different from putting it here.
Okay.
Yep, so I have to specify where I'm putting that. Okay, but we still have 1, 2, 3, 4, and 1, 2, 3, 4 was a bute, yep, with ane when it was all single bonds, but we know we have butene since we have double bonds. Okay.
Yes. So now I talk about the double bond
Okay. So that's where you need to specify. So we start counting 1, 2. The double bond is on the carbon 2, so that is 2 butene. That specifies that it's right there. But if, like you, that's a great question, I put it right there, we now have, keeping the number low, the double bond on the first carbon. So now we have 1 butene.
Okay. But the name is going to be exactly the same.
The butene, because you have 4 carbons with a double bond, yeah. And then the 1 specifies where that double bond is at.
And then, do you always start counting the carbons from right to left?
You conventionally, you start counting in the direction that's going to give you the lowest number. Yeah. I mean, you could go 1, 2, 3 butene, technically, that would get you there, but the convention is to always count in the direction that gives you the smallest number. 1.
Okay, let me make a note of that.
I mean, any decent chemist will be able to figure it out, but generally, yeah, you keep those numbers as small as possible.
Okay.
It's just like rules we've all agreed on. Okay.
Yes.
So we've covered alkanes, which is all single bonds between carbons. Alkenes, which has these double bonds somewhere. Now we're going to take a look at triple bonds, the alkynes. Okay. So let me give myself a little room. Yeah, then this new whiteboard, yeah, Microsoft update is not, I don't like it. I was perfectly happy with it the way it was before. But okay, now we have a little room. So alkanes, alkenes, alkynes. Any guesses as to what I'm going to see with alkynes? Is that single bonds and then double bonds?
Well, this one is going to be a triple bond, right?
Yes. Okay. Now see, I have the 4. I have 1, 2, 3, 4 on that carbon, and 1, 2, 3, 4 on that carbon. We got all our covalent bonds. We got all our electron shells filled. That's a stable molecule. Okay. Okay. And what was the prefix for something with 2 carbons?
Ethane.
F. Well, ethane if it's an alkane, but we have ethine with that triple bond. Yeah. So 2 carbons with a triple bond between the carbons is ethyne. Likewise, let's see where I'm probably headed with this. No, ene is with 2. There you go. Yep. Alkane, alkene, alkyne. And let's go ahead and just finish the series here. Okay. Butane. And in this case, and is it 1 butane or 2 butane?
That's gonna be 2.
No.
1 and 2.
1. 2 butane. Mm-hmm.
Okay, it means 2. 2. Okay.
Okay. Alkene, alkane, alkene, alkyne. Count out your carbons to get that, and then attach the appropriate suffix based on the number of carbon-to-carbon bonds. Okay, good. Excellent. It's a great starting place. So now, and you've probably seen some of these in previous quizzes, but it doesn't hurt to go back and take a look, right?
Yes.
Then you start attaching groups to those carbons for IUPAC naming conventions. Things besides hydrogen to the carbons. Okay. 3 carbons. At this point, we know that is propane, right? Okay. Now I'm going to put a chlorine up there instead of a hydrogen. Okay, I'm going to take a hydrogen off of that and replace it with a chlorine, right?
Yes.
Now, I need to let another chemist know what we have here. Okay, so we start counting from the number that will give us the lowest number for the substituent, and this would be carbon 1. Okay?
Okay.
Let me change colors here. That looks like a bond. 1, 2, 3. So I have 1 chloro, right? For this chloro right here.
Yeah.
And you already said that is propane.
Okay. Propane. Yes.
1 chloropropane. Now I'm going to change this up a little bit for you. What do I have now?
2 chloropropane.
You are 100% correct. Nicely done.
Good. Thank
you. Okay. Now I'm going to ask you a little bit of a trick question. I'm going to tell you ahead of time.
Okay.
Now what do I have?
Now, because you said that it's a trick question now.
Mm-hmm.
Propane.
Okay. It's still propane. However, remember we want to keep this number low, so we have to change. Okay. Because you can see if you flip it, and this is chemistry, it's flipping stuff around in your mind. If I flip the 1 over to where the 3 is like that, we have exactly the same thing, right?
Okay. Yes.
Okay. So now let's.
Wait, I'm sorry.
Yeah.
So the answer for that is that one is the number 2 chloropropane or 1 chloropropane?
Oh, it is 1.
Okay.
Just like that.
Okay.
Okay. Now let's play with our propane a little more. Let me just say, okay, you walk into a test and you get a little something like that, a bromine right there. And I'll work through this one for you. So we start with counting out the number of carbons. We have 3 carbons, so I know it's a prop.
Yeah.
There are no double bonds between carbons, so I know it is a propane. So we got our carbon backbone. Okay, so in this case, it doesn't matter which end you start from. You just got to keep track of it because you'll see in a second that it won't matter. I'm just going to start counting from the right. 1, 2, 3. Okay, and then you name the attachments, substituents, in alphabetical order. That's another convention we have, alphabetical order. So bromo is in front of chloro, right? Oop, I lost my chloro. Okay, so I have 3 bromo, 1 chloro, propane. Okay, 3 bromo, 1 chloro, propane.
Okay, and then one question.
Yeah.
Okay, so the carbons you're gonna start counting from the 0 all the time, or does it matter if you start counting for?
Yeah, in this case, it wouldn't matter. It would be perfectly okay. People would know what you're talking about if you,
Because if I change them from the left to right,
right. And that would be just fine. That would be an acceptable answer in my classroom.
well, let me 1, 2, 2, 3. Okay, okay.
Okay.
Good.
Okay. Okay, so I'm going to throw another one up here. I'm just making something up. Okay. So, okay, you tell me. You walk me through it. What's your carbon backbone?
So that one is 4 carbons and then a double bond butene.
Okay. Well, tell you what. Let's place that double bond.
Yeah.
Okay. What type of butene do we have?
2.
Okay, 2 butene. All right. Now continue with your chloro and bromo.
And that's going to be 2 chloro and 4 bromo.
Okay.
So the name is going to be 4 bromo, 2 chloro, 18 with E.
Yeah. 4 bromo, 2 chloro, 2 butene. You were right. Yeah, you feeling like you're getting the hang of it?
Yes. Yes.
Good. I am glad to hear that. So, so something else before. What was I going to say? I was going to move on to. Are you familiar with the skeleton structure of things? When chemists get like lazy, they get tired of writing lots of C's and BRs and all this stuff. You can indicate it with just lines, and at the end of every line is a carbon. So I'm gonna draw this first structure and skeleton. So here's one carbon, there's two carbon, there is the third carbon. Okay? So this is equivalent to that. Carbon 1, carbon 2, and carbon 3, right?
Okay.
That makes sense?
Yeah.
Now, then I would have to add the chloro here and the bromo here to make it exactly the same. So this is, those are both 1 bromo, 3 chloropropane. This is just like a shorthand way of seeing it. And let's do the skeleton structure of this one here. 1 carbon, 2 carbon, 3 carbon, 4 carbons, right? With a double bond between carbon 2 and carbon 3.
Oh.
Okay? With that chlorine right there, and with that bromine right there.
I see it. Okay. Okay.
Because yeah, so if you're on a test and you might see something like that, and you need to know how to name it, or draw me 1 bromo, 3 chloropropane in skeleton form, then you would draw that right there.
Okay. Yeah, that makes sense.
Okay, good. Just wanted to touch on that just to make sure that you didn't run across those and go, what were they talking about?
Yeah.
Okay.
Oh my God, that makes more sense. I was going to really talk on it with the double bond. I was like, well, I'm going to have to put the line, but
Yep.
now I got it.
Alkene, alkane, alkene, alkyne. All right. So now our line structures fairly straightforward. So once you get up to 3 carbons, they can start wrapping around and binding to each other in ring structures. Just happens. Just is what it is. So this, and then to designate that, you just add the prefix cyclo. So that is cyclo. 3 carbons with single bonds, cyclopropane.
So cycle is when it's 3 carbons with a single bond, right?
No, cyclo is anytime it's a ring structure. When the carbons have bound back to themselves to give you a ring.
Okay.
Yeah. It doesn't have to be 3 carbons. In fact, let's look at this one. And then the skeleton structure is a triangle, right?
Yes.
Okay. Now what do we have? We got 4 carbons in a ring structure with single bonds.
Yeah.
Cyclo, what?
With 4 carbons and 3 carbons.
Yep. Okay. Cyclopentane looks like a house. Now, those are somewhat, but the one that you're going to see over and over again because it's stable-ish is 6 carbons.
1, 2, 3, 4, 5, 6. Okay.
Okay? Or cyclohexane.
Hexane.
Okay? So let's circle back and take a look at the hex with 6 carbons. So you can start adding double bonds. That's cyclohexane. Double bonds make it, that'd be a cyclohexene. Okay? And you don't have to designate 1, 2 because it doesn't matter where the double bond is. But, yeah, double bond here. So 1, so we'll call this, for instance, 1, 2, 3, 4, 5, 6. Those are my carbons. So that would be 1, 4, so 1, 4 cyclohexene. Okay, 1, 4 cyclohexene. Excellent. Okay. Yep. Yep. So now we're going to get to a very important structure called with 6. I'm going to get rid of all these just so we don't get confused. It does have 6 carbons. And it's got alternating double bonds. Every other carbon has a double bond. Okay. So that is, well, 1, you can call it 1, 2, 3, 4, 5. So 1, 3, 5 cyclohexene. 1, 3, 5 cyclohexene. But the term we use all the time is benzene. I don't know where that came from, but a 6 carbon ring with alternating double bonds is benzene. And you see benzene rings all the time. Now, don't get a benzene ring confused with cyclohexane. Cyclohexane doesn't have those double bonds. If you see that, that is benzene. And there's a shorthand that's used so often. There's a shorthand we use all the time for a benzene ring. We just draw a circle in the middle. That's benzene. Or 6 carbon ring with alternating double bonds.
Okay, if I see the figure with the circle in the middle, it's the same like the other one with the double bond?
Yes. Yep. Okay. So benzene, very important benzene. In fact, important enough, I'm going to take a little time and look at just benzene rings. Keeping in mind it's not an alkane ring, it is a benzene ring. Okay, so here we go. Here we go, it's a benzene. So guess what? We can start attaching things besides hydrogen to benzene rings. Okay. So let's see, I'll attach, we'll go back to our friend bromo. And since it doesn't matter where you put it, you don't have to number it. You start numbering number 1 where the constituent is that will keep the numbering the lowest. So that's just bromo benzene. Technically 1 bromo benzene, but most people just leave the 1 off because any carbon you pick is 1. But okay, that's that our friend chloro. Okay, so I'll let you go ahead and take over. What would you call, how would you name this aromatic compound? Okay, bromochloro, great, but we do need to place them because we're going to have to designate which carbon that is. So I will say okay. No, we'll start with bromo 1, 2, 3. Okay. So let's go ahead and name that compound. Okay. Okay. All right. So, and you know what? Let me start adding. So sometimes you can have other alkyl substituents put on. And so I'm going to get a little tricky on you here again. Okay. Now remember our skeleton. There's 1, there's 2, there's 1, there's 2. Ooh. Okay. And remember, you see my substituent here is 1 carbon, 2 carbons, 1 carbon, 2 carbon, right? So these are both with 2 carbons with single bonds.
Okay, so if it's 2 carbons, it's going to be, if it's a single bond,
ethane, or ethyl in this case. Okay. So let's see. 1, 2, 3, 4. Okay. I'm going to go 1, 4, di for 2 of them, ethyl, benzene.
So you have 1, 2, you see that,
And it's di. Okay, so di means you have 2 of the same thing attached. Okay, just like, let me change this up a little bit. If instead of an ethyl, clean this up a little. Ooh, oh, ooh, ooh. Okay. Put a chloro here and a chloro there. So I have 1, 2, 3, 4. 1, 4 dichlorobenzene. And if I added another chloro, 4, 5, 6, 1, 4, 6 trichloro. Benzene. 1, 4, oh. Dichloro, trichloro. Yeah, so if you have multiples of the same structure, you can start, combining them into one. Instead of 1 chloro, 4 chloro, 6 chloro, you just say trichloro.
1, 4, 6 is trichlorobenzene. Okay.
Yeah.
Can we do one more? The one that two carbon.
Two carbons, so like. Oh, sure.
Yeah.
I think so. We have a benzene. Then I'm going to draw it 1 carbon, 2 carbon, 1 carbon, 2 carbon. Right, that one. Yeah, I just did it in skeleton before. So we know we have an ethyl and an ethyl.
Mhm.
If we had 3 carbons, we'd have a propyl.
Yeah. Okay.
4 carbons would give us butyl.
Yeah.
Yeah. So let's just go back to our ethyl.
Mhm.
Okay. So 1, 2, 3, 4. You see, it doesn't matter which direction. I could go 1, 2, 3, 4. It gives me the same thing in either direction in this case. Okay. So you're right. We know we have a benzene ring
Yes.
for this aromatic compound. At carbon 1, we have an ethyl. At carbon 4, we have another ethyl.
Mhm.
So we have 1, 4 diethyl
Yeah.
benzene.
Okay. I'm sorry, I have to write it down so that way.
Oh yeah, absolutely. Yeah. Take all the notes you need. Take all the time you need.
Okay.
Okay. You ready for the next concept?
Yeah.
Okay. So do you know the difference between cis and trans isomers when it comes to alkyl? Okay.
No.
That's a good thing to know. So first thing to keep in mind, if you have an alkane, the single bond, there's no isomers, right? Because they can just spin around each other willy-nilly. You just have a single bond. See what I'm doing here? They can just spin any which way. So it doesn't matter. Doesn't matter if the chlorine's up here. They can just spin wherever they want to around these bonds. Okay?
Okay.
Now things get interesting when we have double bonds and triple bonds. So we have butene, right?
Mhm.
Or
Yeah.
no, ethene. I'm sorry, that's ethene. And it doesn't matter if we have hydrogens attached there because it doesn't matter which hydrogen is where. However, since you have that double bond, they are locked in. So those carbons have to move together. They're locked in a plane, okay? They can't spin like they could around a double bond. So it is going to matter if I put a substituent right here because there's no rotation around that bond.
Okay.
Okay, so notice I put these chloros above on the same side of that carbon. So that would be cis dichloro, right, for the 2 carbons, ethene. Make sense?
Yes, I think.
So cis, so these are on the top. That's the cis dichloro, 2 chlorines, and an ethene for the double bond.
Mhm.
However, if you put a chloro up here and you put another one down there, now we got issues because this these chlorines can't rotate around a double bond because the double bond keeps them always in the same configuration across from each other. Now, when the substituents are across from each other, that's called trans. Cis on the same side, trans when they're on opposite side.
Okay.
So this would be trans, once again, dichloroethene.
Cool. So transform there to the opposite side. Okay.
Okay, trans-dichloroethene. And then you can start expanding. Let's see, let's look in your book here, see what examples they gave us here. Mm-hmm. Yeah, well, that'll be good enough for now, I think. If you just keep those track. The difference between cis and trans is basically you're locked in a configuration. So the subset, you need to tell the person that you're dealing with where those substituents are in relation to one another. Because it makes a huge difference. If they're far, chlorine is very electronegative in this case. If they're on the same size, they're going to try and repel each other. So that's going to change how the molecule looks. If they're far away from each other, it's going to be more stable. So it's very important. Let's see, cis and trans reactions. And, oh, something I always like, did you have a pretty good grip on balancing chemical reactions? Was that?
No, I don't.
Okay, so that'll be a very important one for us too. But since you're on organic chemistry, I at least wanted to make sure that you were able to follow the lectures more or less, or at least have a fighting chance of following the lectures.
Yes. Thank you, I really appreciate it.
Yeah, not a problem whatsoever. So let's see if they have balancing equations, and then yeah, I'm sure your brain is probably starting to get filled to capacity. So let me just let's see, do a electrolyte. Blah, blah, blah. Oh, that's pretty straightforward. But I want to balance equations. We do at least one balancing problem, because sometimes it'll be enough to click. 228. Let's try. Okay. Oh, I'm looking around page 230, back on chapter 7. Yeah. Now let's just do a simple combustion. That's a great place to start.
Okay.
You're just taking an organic molecule, like we've been looking at, and you're combining it with oxygen and getting water and carbon dioxide. Okay, so let's see. Hopefully you'll be able to more or less follow along. Methane, remember, one carbon, single bonds. Excellent, you got methane. Plus oxygen, and we have our combustion with our products being carbon dioxide and water and energy, which I'm not going to concern myself with. Okay, so first of all, we have to determine whether or not a given chemical equation is balanced. So let's count up our carbons first of all. See, I got one carbon here, I got one carbon here, I got 4 hydrogens here, I only got 2 hydrogens over here, and I have 2 oxygens here, and I have 1, 2, 3 oxygens, right? Yeah. So it's all out of whack currently. Okay. So it's kind of a bit of an art. So we need more hydrogens on the right, correct?
Yes.
So let's go ahead and we'll do that by increasing the amount of water by a factor of 2, right?
Mm-hmm.
Now I have 4 hydrogens. I have 1, 2, 1, 2, 3, 4 oxygens, right? Right. 1,
Yes.
2,
Yeah.
3, 4.
3, 4. Uh-huh.
Uh-huh. And I have 4 hydrogens, 1 carbon, 1 carbon, and only 2 oxygens. So we're getting closer.
Yeah.
So what I would need to increase the number of oxygens on the left to balance out the number of oxygens on the right, correct?
Yes.
So let's do that. So we have 2 over here, so let's double the amount of oxygens over there. Now let's see how we're doing. So we have 1 carbon. Now let's switch colors. 1 carbon, 1 carbon, 4 hydrogens, 4 hydrogens. I have 1, 2, 3, 4 oxygens. I have 1, 2, 3, 4 oxygens.
Oh, I see. Okay.
So carbons equal carbons, hydrogens equal hydrogens, and oxygens equal oxygens. Now we have a balanced, let's see, where's my count? A balanced chemical reaction.
Yes. Okay. That makes more sense. Okay.
Mm-hmm. And then that,
Water.
what was that?
No, no, no. I'm just something.
Well, let's do another.
Okay.
We're going to have aluminum and chloride reacting to form aluminum chloride. Yep. Okay. So if you see something like this, what's really useful is to keep in mind from math the concept of a lowest common denominator.
Mm-hmm.
So we have a chloride 2 on the left. I got 3 on the right, right?
Yes.
So obviously our chlorides are out of whack. We need to get them together. So what is the lowest common denominator between this 2 on the left and the 3 on the right? What's the first number they would both divide into?
1.
No, it's got to be the first number that both 2 and 3 go into, and I'll tell you, is 6. 2 goes into 6 3 times. 3.
Oh, okay.
Mm-hmm.
Yes. Yes.
So we're gonna end up with 6 chlorides on each side. So let's do that. So we'll need 3 of the Cl2s to get to 6, right?
Yes.
I'm gonna need
Okay.
2
Yeah.
to get to 6.
Yes.
Okay, this is all well and good, but now I have 6 chlorides and 6 chlorides. However, I have 2 aluminums. So what am I going to have to do?
Correct. Yeah.
Okay, now I have 2 aluminums on the left. So our aluminums equals the aluminums, and my chlorides equal my chlorides.
Okay. Yeah. Okay. That makes yes.
And we can get into a pretty deep rabbit hole with balancing equations. But this is a good starting place. See, at least
Yeah.
you have the concept of what we're doing.
Yeah.
Yep. Okay, good. I think that's a great spot. So if you aren't familiar with balancing equations, I suggest you go back to around page 230 and work through section 7.6. So that'd be 229 through 233. And there's some of the stuff I didn't get to, and we can circle back to balancing chemical equations, because that's also a very important concept you need to internalize to be a good chemist.
Okay, so you said page 37.6 and
Yeah, basically page 229 through page 233.
okay.
Yeah, and it's, looks like, section 7.6, 7.7, yeah.
Okay, yes. For teaching a mathematical field, this makes more sense at first.
Good, good. Well, you're taking your first steps on mastering some of these basic concepts. And like I said, I wish I could have gotten more. Tell you what, let's get together at some point. With your permission, we can either schedule it now, or you can get back to me. But let's schedule a time to, at the very least, just go through balancing chemical equations.
Yes, that's totally fine. Do you want to do it next week at the same time?
Sure. So 11 o'clock
Yeah.
on.
Something early for that?
Oh, you know what? Actually.